Welcome back. Today we're playing a little bit with our MIG welder. We are fitting that inverter drive here. Oh, we actually powered it up already. We're using that inverter drive to provide three-phase into our MIG welder. The problem is, if you run that thing on single phase, it just doesn't weld very nice, and you're limited with the output power as well. So what I did, be careful, it's all powered. It's basically just hooked up for testing here. That's the main contactor, and this cable goes back into that inverter, basically where the motor wires go, all three phases. These two wires, the blue wires, they are actually going down to a spare contact on the contactor, and obviously mains power goes into the inverter. And if we power everything up, here we go. That pulsing is two issues. One is the wire feed, and the other one is I need to change a few parameters on the inverter. I set the maximum frequency to 53 Hz, which is about right for that welder, because it's a 220 volt welder. 220 380. We have 230 volts, usually a little bit more, and so that's about right. The drive does well, it doesn't get hot. We are doing much better. We're now on position 4, whereas before, to get a reasonable weld with that feed, and yeah, that pulsing is actually the inverter, so we're going to sort out. It's basically just a brief look at it, how it works. Again, be careful, electricity is dangerous, it may kill you. If you don't know what you're doing, just don't do it. Yeah, the frequency source is set to external with that wire, just the 10 volts directly into the input, and these are just the forward run connections. So if everything works as I wanted, I just fit that drive inside, and I have a three-phase powered MIG welder from single phase. So don't know if that's gonna work, but let's try that. That's the first phase. Don't know if that's visible. Let's try that. That's the first phase. Sorry, it's all needs 3 hands for that. Second phase, and that's the third one here. So that's what we wanted. I'm pretty happy so far with the tests, and if the wires get shorter, that mains wire is pretty long as well, so if everything gets a bit shorter, it's better. We just need to find the space. There's not much room inside. Perhaps we put it on the other side. There's some room under the where the roll goes. If we put that somehow horizontal or so, or just here, I don't know. We'll see. We'll find a space. I don't want to have it outside. The other option will be relocating the rectifier, which I don't really want to do. Maybe we can squeeze it into that spot, I don't know. We'll see. I'm gonna make some drawing and put that into the video as well, just to show the idea behind it. It's pretty simple. It acts like a motor, more or less, like a three-phase motor, because the transformer is actually a three-phase transformer. And if you run single phase, you only use 2 coils. The third coil isn't powered. There is something coming out on the secondary side, but it's just not right. It doesn't weld very nice. We're gonna explain later why. There is another reason why it doesn't weld properly on single phase. As far as I can see, it welds a lot better than before. I just need to sort that ramping thing. The ramp times are set to 0.1 second, which is the lowest you can set. So as soon as you turn it on, it instantly comes on and powers the transformer. Alright, let's go to the drawing board and talk about the details here. We're actually fitting that to a 3-phase MIG welder, which is rated 220 380 volts. We want to run that thing on single phase, 230 volts. So we switch it for 220, but we still have the problem that we need 3-phase. It runs on single phase, but it only does probably about 60% of the power. So it's only good for sheet metal welding rather than doing some proper weldings. So you can't run these things off a phase converter because it just doesn't work properly with a welder. So I came up with the idea using a VFD, and in our last video we showed the teardown of that Chinese, what's the name, Huanyang inverter, because I wanted to see what's in it, and we decided it's suitable for what we're gonna do. There is some reserve on the components because a welder in general is quite stressing for an inverter. It's a lot more challenging than a motor. So what we basically do, we have our 3-phase welder where 3-phase comes in here, and basically it has a contactor, and this is switched by the trigger, and this end goes to the transformer. So what we do, we cut these wires, and basically the contactor becomes our VFD, and we go in with 230 volts and come out with 3 phases, and that goes to our transformer. There are some range switches in the middle here, but we don't really care what they are. So all we do is using a VFD, which we set to, normally I would set it to 220 50 Hertz, but what we did, we set it to 230 volts 58 Hertz. The reason for that is it gives me a little bit of higher frequency, and the welding looks a bit better and the inverter behaves a bit better. There's no particular reason for it, was just experimenting, because normally you would set that to about 53 Hertz or something like that, because 220 to 230 is about 3 Hertz more. Essentially we replaced the contactor with the VFD. Our VFD got a run input, run and usually ground, and all we do is using that contactor, which has an auxiliary contact down here, and we use that and connect it to this end. We also have on this one, it's VI and plus 10, which just bridge that. So the inverter always runs on full power. We talk about the parameters later. Essentially we are creating a proper 3-phase signal for our transformer from a 230 volt input, because if you look at the transformer is wired in delta, so we got 3 coils of the transformer, and they all wired in delta. So the phases go here, here and here. So for the drive, for the inverter, it doesn't really matter if this is a drive or a motor, except the drive can do vector mode, so this needs to be turned off. The drive has to be run in voltage frequency mode, which all these cheap drives usually do anyway. I just found out there is no option for vector or field oriented control or something like that. It just doesn't do it, which is good for what we're gonna do. So that's the theory. So let's do that a bit better actually. So we have our VFD, we have our transformer. So this is our welding transformer. Forget about the switches. Our VFD gets 230 volt here, and from the welder we only need run and perhaps the speed, but that's full. So this is actually plus 10 volts. It's just linked. So the inverter has always full speed. That means maximum frequency, and our settings are 230 volts, 58 hertz. That's what I found are the best settings with my welder. Essentially, the trigger of the welder will still run that contactor. You can replace that by a cheaper relay, which I probably do, because you don't need that big contactor anymore. Simply speaking, the VFD is our contactor, our power contactor in the welder. Providing you can set your welder to 230 volts in delta. I was lucky that welder is 230 delta 380 star. It's a pretty old machine. So in star it would just look like that. You got your coils and everything is linked together here, and the mains goes here. And that's the high voltage, like a motor. There's no difference between a transformer and a motor. There are differences, but there are, from an electrical point, star delta circuitry, there is absolutely no difference. Okay, let's look into the reason why I'm aiming for a higher frequency. If we have a single phase welder and a bridge rectifier, we will get, assuming this is 50 Hz AC, we will get 100 Hz DC. If we have a three-phase rectifier, this will be 150 Hz. So on a three-phase, this will be 150 Hz. So if I go for a higher frequency, this will be, with a single-phase rectifier, will be 116 Hz and 174 Hz on a three-phase rectifier. The thing is, it gives you better welds because it's closer to DC. There is not much ripple on it, and that's exactly the problem. If you run our transformer in delta and only feed these two phases, the last coil has some sort of residual voltage which is lower. You can put a capacitor on there, but it doesn't really work well. So on the output, because we have the same, usually in star, we have the same circuitry here. This last coil will produce less voltage. So we're basically just using those two coils for power, and that makes the welder a single phase welder, even if it's got a three-phase transformer, and you don't use the full capacity of the transformer as well. It's quite a bit of theory, which is not necessarily important if you just want to convert your welder. But that's the reason why I'm trying to get three-phase into it, because then I use the full capacity of the transformer, and I also get 150 or 174 Hz out, which gives really nice welds. I was really surprised how good it looks. It does weld as I was used to it now. So back to the roots. 230 volt into the VFD. Out comes three-phase 230 volts. The transformer is designed for 220, so we can go a little bit higher with the frequency to compensate for the higher voltage. I found 58 works okay for two reasons, because the current limit on the inverter, that's a 3 kilowatt Chinese 3 kilowatt Chinese inverter, which is probably not good for 3 kilowatt. It's maybe 2.5 or so. essentially the maximum current here can be 11 amps. That's what the VFD is rated for. So with the 58 Hz and 230 volt settings, we just about hit the current limit at full power. The welder, I think it can do up to 15 or so, but the problem is the mains power. I only have 13 amps on the input, so that will limit our possibilities anyway. So let's go back to the welder and have a closer look at the whole thing and see how the welds are looking, or how it welds. I didn't really do proper welds, I was just testing it. But I could see there was a lot more heat going into the welds than before, so it was welding a lot better, of course. So we messed around with the settings a little bit, and it seems to work a lot better now. That's pretty good, and that's on 4. I think I can't go much higher, otherwise the drive goes into overcurrent. We'll see. A bit more wire feed. That looks pretty good. I wonder how much that was, but that feels like in the old days. I changed the frequency to 58 Hz, messed around a little bit with the parameters on the drive, and I'm more than happy with what it does. The question is how long it's gonna last, because it's quite stressing, because if you do weldings, the current is very intermittent, and yeah, apparently it does well. So I'm okay with that. The transformer sounds a bit higher frequency, obviously, but let's crank it up full and blow the fuse. Yeah, you can hear the transformer is now screaming because of all the square wave stuff which comes out of the inverter. Feels like a pretty good weld here. Yes, I'm happy so far. We're gonna tweak a little bit with the inverter settings, but I think we got a sweet spot here. Maybe I crank up the frequency a bit further, gives us better welds, and then we're gonna fit that thing into the case here. We just need to find a spot for it. Alright, so far so good. Let's go to the drawing board and explain what we've done here. The VFD, the inverter drive, is a Chinese 3 kilowatt inverter. I probably would go for a 4 kilowatt if I would try it again, just to have the extra capacity. There is a link to the previous video where I took that inverter apart and had a closer look at it. Yeah, I'm happy so far with that. We'll see how it comes together. And obviously there will be another video when everything is in place and working. This was basically just a quick test to see if it works as expected, and apparently it does. It needs a bit of wiring and setting up a couple of things, and then we do a proper drawing as well. It was just rushed out on a paper to give you guys an idea how it works and what the thinking behind is. Alright, that should be it from this episode. Thanks for watching, thanks for subscribing. Until next time.